Good morning. Welcome to problem solving session on permutations and combinations. In this session, let us solve few problems on permutations and combinations, and most of these problems are from A. Das Gupta. Let us see. First question. A letter lock consists of 3 rings, each ring marked with 10 different letters. A letter lock, a typical lock what we use, which is usually of numbers. This contains 10 different letters and this has 3 rings in it. Find how many ways it is possible to make an unsuccessful attempt to open the lock. Let's say this is our letter lock. This has 3 rings in it. First ring we can operate in 10 ways. And is always a multiplication sign. Second ring can also be operated simultaneously in 10 ways. And third ring we can again operate it in 10 ways. So effectively we can operate the lock in 10 cube ways. But we are counting only unsuccessful attempts. One of these attempts will be the right attempt. So that if we remove 10 cube minus 1, that is 999 attempts are right attempts. So this question is based directly on the fundamental principle of counting. Okay. Let us look at next question. A telegraph has a number of arms and each arm is capable of taking 4 distinct positions. We can call this technology obsolete. Still, every arm can take 4 distinct positions. Let's say there are n arms. Each arm we can operate in 4 ways. So on the whole we can operate the telegraph in 4 into 4 into 4 into so on up to each arm can be operated in 4 ways. This is 4 power n. But in this, one position will be there where all the arms are at rest, that is no signal is transmitted in that case. So we need to remove that. 4 power n minus 1, and this is given to be equal to 1023. So 4 power n is 1024. 1024 is 2 power 10, the most commonly used kilobyte. So n is 5. Your answer will be 5. Next question. How many 10-digit numbers can be made with odd digits so that no 2 consecutive digits are same? How many 10-digit numbers can be made with odd digits? How many odd digits are there? 1, 3, 5, 7 and 9. Using these 5 odd digits, we need to construct a 10-digited number. So first place 10. Let this be the 10 digits. First place you can fill it with any number. 1, 3, 5, 7 or 9. You can fill that in 5 ways. For second place, you cannot use the digit which is already used in the first place. So you can fill second place in only 4 ways. And for third place, you cannot use the digit which is used for second place. No 2 consecutive digits have to be same. So this place again you can fill it in 4 ways. So if you continue the process, every other digit can be filled in 4 ways. So our answer should be 5 into 4 power 9. Now had the question been 10-digit numbers which can be made with even digits. Let's change the question to even digits. Now what will be the change in the question? When we make odd digits to even digits, let us see if there is a change in pattern of answering the question. First place, how many even digits will be there? 0, 2, 4, 6 and 8. 5 even digits. First place can be filled by any 4 digits other than 0. And for the second place, we cannot use the digit which is already there in the first place. So 4 ways I can fill second place. Again 4 ways I can fill third place. So on up to 10th place can be filled in 4 ways. Answer will be 4 power 10. For odd numbers it was 5 into 4 power 9, and for even digits, because 0 cannot be there in the first place, answer would be 4 power 10. Let us look at next question. How many odd numbers of 5 digits can be formed with the digits 1, 2, 3, 4, 5 if the digits cannot be repeated in the same number? Read the question carefully. How many odd numbers of 5 digits can be formed with the digits 1, 2, 3, 4, 5 if the digits cannot be repeated in the same number? So repetition of digits is not allowed. And then we want 5 digited odd numbers. Let's say these are our 5 digits. Last place has to be a odd digit because the number is odd. So last place can be filled in 1, 3, 5, 3 ways. Last place can be filled either with 1 or with 3 or with 5 in 3 ways. Then the remaining digits, first digit, except for the number used in the last digit, I can use any of the remaining 4 digits. I can fill first place in 4 ways. Next place, except for first and last digit, I can use any other digit in 3 ways, in 2 ways, and in 1 way. Or I have 5 digits. For last place I will choose a odd digit in 3 ways. I will put it here, and remaining 4 numbers I will permute them in 4 places in 4 factorial ways. So answer will be 4 factorial into 3 or 24 into 3, that is 72. Next question. Let n belong to natural numbers and n lies between 300 and 3000 if n is made of distinct digits by taking from 0, 1, 2, 3, 4, 5, then find the number of possible values of n, or greatest number of possible values of n. N is a number lying between 300 to 3000. So n has to be formed using the digits 0, 1, 2, 3, 4, 5. Distinct digits, repetition of digits is not allowed. So let us see what kind of a number or how many different possible numbers we can form. A number lying between 300 and 3000 can be either a 3-digit number or a 4-digit number. For a 3-digit number to be greater than 300, first place can be either 3 or 4 or 5. First digit I cannot use 0, 1, 2. I can use either 3 or 4 or 5 in 3 ways. And once the first digit is filled, for next digit, except for the number used in first digit, I can use any of the remaining 5 digits. And for the last place, I can use any of the remaining 4 digits. So 60 3-digit numbers can be formed. And looking at 4-digit numbers which are less than 3000, first place cannot obviously be 0. It can be 1 or 2. It cannot be 3 or 4 or 5. So first place can be filled in 2 ways, either with 1 or with 2. Second place can be filled with any of the remaining 5 available digits. Third place in 4 ways, and last place in 3 ways. So 60 into 2, 120 ways. So there are 120 4-digit numbers and 60 3-digit numbers which are possible using the given constraints. So total we will have 180 numbers. Let us look at next question. How many 7-digit numbers can be made from the digits 1, 2, 2, 2, 3, 3, 5? And how many of these are odd? I am given 7 digits here. 7 digits and I want a 7-digit number. So I have to simply permute these 7 digits among themselves. 7 digits can be permuted among themselves in 7 factorial ways. But here 3 2's are identical, so I have to divide by 3 factorial, and 2 3's are identical, so I have to divide by 2 factorial. So this will be the answer for the total number of 7 digited numbers that can be formed using 1 2 2 2 3 3 5. Now coming to the question of how many of these are odd. This question can be done in 2 ways. First method, a odd number should always end with a odd digit. So last digit can be 3 or last digit can be 1 or 5. We are separating these two cases because there are 2 3's whereas there is only 1 5 and 1 1. So consider these two separate cases. When last place is 3, remaining 6 digits have to be permuted in 6 places. We can do that in 6 factorial by only 3 2's are identical, we have to divide by 3 factorial. And when we are putting 1 or 5 in the last place, we can choose that in 2 ways, either 1 or 5. And once the choice is made, I have to permute the remaining 6 letters in 6 places. We can do it in 6 factorial ways, divided by 3 2's are identical, 3 factorial, and 2 3's are identical, 2 factorial. This is the difference between this previous assumption and this assumption. Divide by 2 factorial will be extra. So 6 factorial by 3 factorial is 120 plus 6 factorial by 3 factorial into 2 factorial is 60. So 180 cases here. And with 5 another 60, which makes it 240. Alternately, the total number of odd numbers what we get using these digits. Let us see the second method. We want total number of odd numbers. Total number of odd numbers is total numbers whatever we counted, 7 factorial by 3 factorial into 2 factorial, which we got it to be 420, minus all possible even numbers. How many even numbers are possible? Last place has to be 2 for a even number. There is only one even digit given, and remaining 6 letters can be permuted among themselves in 6 factorial by 2 2's are identical, 2 3's are identical, 6 factorial by 2 factorial into 2 factorial. 2 3's are identical and 2 2's. 1 2 we already used it here. 2 2's are identical. 6 factorial by 2 factorial into 2 factorial. So 7 factorial by 3 factorial into 2 factorial is 420. We already calculated that. Minus 6 factorial by 2 factorial into 2 factorial. 6 factorial is 720. Divided by 4 is 180. And this difference would be 240. So 240 odd numbers are possible. Second case would be better compared to the first method. How many numbers greater than a million can be formed with the digits 2 3 0 3 4 2 3? Greater than a million. Million is how many digited number? Million is a 7 digited number. It is 10 lakhs. This is a million. So for our number to be greater than million, we have 7 digits. Our number has to be exactly 7 digited number. Our number has to be exactly 7 digited number. First place cannot be filled with 0 and there is no 1 here. So first digit can be filled with either 2 or 3 or 4. First place can be filled with either 2, or 3 or 4. So here 3 is a separate case, filling separately first digit with 3, or let us fill first digit by 2, or let us fill first digit by 4. Now when I put 3 in the first place, I have 6 digits to be permuted among themselves. I can do that in 6 factorial, of which 2 3s are identical, 1 3 is already used, 2 3s are identical, and 2 2s are identical. So we can permute that in 6 factorial by 2 factorial into 2 factorial ways, that is 180 ways. And when first place is 2, now I have 6 more digits to permute, 6 factorial by 3 3s are identical, 3 factorial, which will be 120. And then when first place is 4, again I have 6 digits to permute. I can permute them in 6 factorial by 2 2s are identical and 3 3s are identical, 3 factorial into 2 factorial. So this will be 120 by 2, which is 60. So 60 plus 120, 180, 182 is a 360. Our answer would be 360. Alternately, same question can be done in this way. I will permute all these 7 digits among themselves. I can do that in 7 factorial by 3 3s are identical, 3 factorial, into 2 2s are identical, 2 factorial, minus how many of these permutations start with 0? We cannot count them as numbers greater than million, so we have to remove them. First place I will put 0. Remaining 6 places I will permute them in 6 factorial by 3 3s are identical, 3 factorial, and 2 2s are identical, 2 factorial. So answer will be 7 factorial by 3 factorial into 2 factorial minus 6 factorial by 3 factorial into 2 factorial. 6 factorial into 3 factorial by 2 factorial we can take common. 6 factorial by 3 factorial into 2 factorial we can take common. 7 minus 1 is 6. 6 factorial by 3 factorial is 5 factorial, 120 by 2 is 60. Multiplied by 6 it is 360. Okay, so this is for today. Let us see the next session in next class.